Good day. My name is TCC and we are Cloud8 from Lab Session 1A. Our group member is DIVIYAH, CHONG, and we will presenting our student attendance management system deployed on AWS cloud infrastructure. First, this is our VPC dashboard in AWS. We created a VPC named Student Attendance System VPC with a VPC ID. This VPC is in available state. In VPC details section, we can see VPC ID and DNS resolution and DNS host names are enabled, allowing our EC2 instance to communicate properly within the network. Next, this is the resource map of our VPC. This diagram shows our VPC, subnets, route tables, and internet gateway. We created multiple subnets across different availability zones, including US East 1A and 1B. These subnets are actively used by our system. Additionally, the subnet in US East 1D is reserved for Phase 3, where future system expansion will be implemented. Next, we move to security groups, which act as a virtual firewall for our EC2 instance. Our main security group is named Attendance Server Security Group. In details, we can see security group name, security group ID, description, VPC ID. This security group has 2 inbound rules and 1 permission entry for outbound rule count. For inbound rules, HTTP port 80, this allows user to access the website through a browser. SSH port 22, this rule is used for terminal access, allowing us to configure and manage the server securely. Now, we introduce our EC2 instance named Student Attendance Server. The server is currently in running state using T2 micro instance type located in US East 1A hosted inside our custom VPC. This EC2 instance runs our attendance management web application. To ensure stable access, we configure an elastic IP address for our server. The elastic IP ensures that the public IP does not change and the website remains accessible even after reboot. Using the elastic IP address, we can successfully access the website. Now, we will demonstrate the student attendance management system. And this is the home page of the system. Attendance management system including list of classes, list of students, attendance management section, and attendance report section. In the list of classes section, we can add a new class and subject. After clicking add new, we can add new class name and subject. In this demo, we use testing 1 and click save. The newly created class will immediately appear in the list. Next, in the list of students section, we can update a student class using the action menu. We can see the newly added class testing 1 is available for selection. We choose testing 1 and save. After update, the student list will automatically refresh. In the manage attendance section, we select a class and date. We can mark student as present, late, absent, or holiday. We can check all or uncheck all so we do not need to mark student one by one. After clicking save, a save successful message will be displayed. Finally, in the attendance report section, we select the same class and date. The attendance data saved earlier will display here. This confirms that attendance records are stored correctly and reports are generated accurately. Also, we can delete classes, then the list of classes will automatically updated. That's all from me. Thank you.
My name is DIVIYAH. I will explain for phase 2. In the search bar, search for RIMDS. Then choose subnet group. Click on students. Use to subnet to create a subnet group. Click on the student attendance database. The RDS MySQL instance is deployed inside the VPC using the subnet group. The database is not accessed directly from the internet and is only reachable by EC2 instance through security group rules. Click on the configuration tab. EC2 console through dbconnect.php. Before that, we need to copy the student attendance database endpoint link. We already import the database dump file into Amazon RDS using this command. In the attendance management system, we will add an example in the class list. After a new class is added successfully, we'll back to the EC2 console to show that the class is updated and it is connected to RDS. That's all for me. Thank you.
Good morning, sir. My name is Chong and I will be presenting for the phase 3, which is the load balancer. Now, first we go to the EC2 first. Then at EC2, we click on the target groups. In here, we had created a target group for the load balancer, which is by using the VPC that I created in the phase 1 and the load balancer here. And we're using the listener protocol, which is a HTTP 80 for access to the website. Then we go to the load balancer. We also create a load balancer here by using the target groups. This load balancer called attendance load balancer. Then this load balancer is to distribute incoming traffic, network traffic to across multiple browser. Then multiple target. Then in here we can see we use back the VPC that created at the phase 1, and also we have multi exec here, which also we create one brand new public subnet for the load balancer called US East 1D. So here got 3 exec. Then for the we can see for the resource map of the load balancer, we can see here listener 88 goes to the rules that we create, then attach the target groups that we just choose and create just now at here. Then you will split it like here, then it also will give us a DNS that connect to the website in the EC2 instance from phase 1. We can try to copy it and paste it in a new tab. As we can see, we can this is the website, same website from the previous phase. We also can read the data here. And that's all from me. and I will be passed to my next member for the phase 4. Thank you, sir.
Good morning, sir. My name is Chia and I will present about the phase 4 of our project, where we implement auto-scaling to automatically adjust the number of EC2 instances based on system workload. The auto-scaling group is integrated with an application load balancer to ensure high availability and scalability. And now we can see the auto-scaling group of this project, which called Student Attendance Auto Scaling Group, with the minimum capacity 1 and the maximum capacity 3. This means that the system can scale up to 3 EC2 instances when demand increase. And next, we can go to the policy scaling, the scaling policies, which call student attendance project policies. This is the target tracking scaling policies configured on average CPU utilization. The target value is set to 50%. And when the average CPU utilization exceeds to 50%, auto-scaling will automatically launch a new EC2 instance. Next, we go to the CloudWatch alarm. This CloudWatch alarm are automatically created by the target tracking scaling policy. When CPU utilization become high, the high CPU alarm enter the in alarm state, which trigger the auto scaling group to scale up. And when the CPU utilization is low, the low CPU alarm enter the in alarm state to scale in. So in this condition, which means that the CPU utilization now is low. Next, we simulate the heavy user traffic using Apache Bench to increase the CPU utilization on the server. Okay, we go to the console. Then we use this. Enter. Okay. By using this, you can see the CPU utilization of the instance, EC2 instance will be increasing. Okay, after waiting a while, you can see the CPU utilization is up to 69.3%. And then we can see the CloudWatch. Yes, like this. The alarm height is become in alarm state because of the high CPU utilization now. And here we can see the auto scaling automatically create a new EC2 instance, which is this. Yes. And then you can see also the before. You can see this. Oh yeah, like just now we copy, you can access to the to the instance. Okay, so which means that the scaling policy is working as expected. And lastly, we can show the target groups, and we go to the target group, and we can see all of the instance is in healthy state, which means that is all can use. And that's all from us. Thank you.